Okay, you guys, let's look at the next problem. Okay, so determine the pressure change when a constant volume of gas at 3.08 atm is heated from 256 Kelvin to 350 Kelvin. Okay, so in here, so we want to know the before and the after, right? So determine the pressure change. So that means we're trying to solve for P2. Okay, we're trying to solve for P2. And with a constant volume at, so it started off at 3.0 atm. So that will be your P1. Okay, and it's heated from, well, it's heated from to here, right? So this should be your initial. So that will be my temperature 1. And my 350K, that's afterwards, right? So that will be my temperature 2. Okay? So we want to figure out the pressure when they changed it at this temperature. Okay? So let's go ahead and get started. Let's plug it in. So this is our Gay-Lussac equation. Okay, so P1, all we have to do is plug it in. P1 will be 3.00 atm divided by T1, which is 256 Kelvin. And that equals to P2, which is what we're trying to solve. And then your T2 is 350 Kelvin. Very much similar to the one up here, okay? And now we're going to go ahead and cross multiply. Okay, we're going to cross multiply. So we're going to go ahead and set it up, okay? So it will be 3.0 atm. And I'm going to just put it here on the side. 3.0 atm. And then we're going to multiply it with 350 Kelvin. And that equals to P2 multiply it by 256 Kelvin. Okay. And now we're ready to, isolate the P2. Remember, we want to have this by itself. Why? Because we got to move that 256 to the other side. And that why? Because we're solving. This is your unknown. So it has to be by itself next to the equal sign. It has to be by itself. So this number needs to move on this other side. So I have to move it. And what do? This is multiplying. So you do the opposite. You do the opposite of multiplication, so you're going to divide it. So it would be dividing 256. Now, the 256, because that's the one you want to move, okay? And then this divided by 256, you do the same thing to the other side. 256 Kelvin. And, of course, this cancels out. And this is exactly how it looks in your review, okay? And now we are ready to solve it. So P2, now 3.0 times 350 kelvins, we've got to multiply that first. That would be 1050, okay? And that would be atm times Kelvin divided by 256 Kelvin. And of course, these cancel out. And then you should be able to get P2 equals, and then you divide it, 1050 divided by 256. That should give you 4.1 atm. And that is your answer.